Throughout human history, we have gazed at the stars and wondered about our place in the cosmos. Among the celestial objects that captivate our imagination, Mars, the red planet, holds a special allure. Its rusty hue, visible even to the naked eye, has beckoned us to explore its secrets. Mars, named after the Roman god of war, is our closest planetary neighbor, yet it presents formidable challenges to human habitation. Its thin atmosphere, frigid temperatures, and lack of liquid water on its surface make it a harsh and unforgiving environment. Despite these obstacles, the dream of terraforming Mars, transforming it into a habitable world resembling Earth, has taken root in the minds of scientists, engineers, and dreamers alike. Could we one day transform this barren world into a second home for humanity? The journey to terraforming Mars would be an epic undertaking, requiring ingenuity, perseverance, and a deep understanding of planetary science. In the following sections, we will embark on a journey to explore the possibilities and challenges of this audacious endeavor. Before we delve into the how of terraforming Mars, we must first understand the why. Mars, as it stands, is a hostile environment for humans. Its atmosphere, composed primarily of carbon dioxide, is incredibly thin, about 1% the density of Earth's atmosphere. This thin atmosphere provides little protection from harmful solar radiation. Temperatures on Mars are far too cold for human comfort, with an average surface temperature of about -63 degrees Celsius, or -81 degrees Fahrenheit. These frigid temperatures make liquid water, a prerequisite for life as we know it, scarce on the Martian surface. Furthermore, the gravity on Mars is only about 38% that of Earth's. While this lower gravity might seem appealing at first, long-term exposure to low gravity can have detrimental effects on human health, including muscle and bone loss. These are just a few of the challenges that make Mars inhospitable for humans. Terraforming Mars would require us to address each of these challenges, transforming a hostile world into a habitable one. Perhaps the most crucial aspect of terraforming Mars is creating a breathable atmosphere. Mars' current atmosphere is incredibly thin and composed mostly of carbon dioxide, making it toxic to humans. Our goal would be to thicken the atmosphere and convert that carbon dioxide into breathable oxygen. One proposed method for achieving this is to introduce specially engineered microorganisms to the Martian surface. These hardy microbes, perhaps similar to Earth's own extremophiles, would consume carbon dioxide and release oxygen as a byproduct of their metabolism. Another strategy involves using large-scale machines to release trapped carbon dioxide from the Martian soil and polar ice caps. This released carbon dioxide would contribute to thickening the atmosphere, though we would still need to find ways to convert it into breathable oxygen. Creating a breathable atmosphere on Mars is a monumental task, but it is a necessary first step towards making the planet habitable for humans. Water is the elixir of life, and any hope of establishing a human presence on Mars hinges on securing a reliable source of this precious liquid. While evidence suggests that liquid water may have once flowed freely on the Martian surface, today it is largely locked away as ice beneath the surface and in the polar ice caps. One strategy for accessing this Martian water involves deploying large-scale drilling operations to tap into these subsurface reservoirs. Once extracted, this water could be purified and used to support human settlements and agriculture. Another ambitious idea involves redirecting comets or asteroids containing water ice to collide with the Martian surface. These controlled impacts could deliver vast quantities of water to the planet, potentially even creating lakes or oceans over time. The process of liberating and utilizing Martian water will be a complex and resource-intensive undertaking, but it is essential for establishing a sustainable human presence on the red planet. Mars is a frigid world, far too cold to support human life without significant intervention. To make Mars more hospitable, we would need to raise its average temperature significantly. One intriguing proposal involves deploying giant orbital mirrors to reflect additional sunlight onto the Martian surface. These mirrors, strategically positioned in space, would act like magnifying glasses, concentrating solar energy and warming the planet. Another idea involves releasing super greenhouse gases into the Martian atmosphere. These gases, designed to trap heat more effectively than carbon dioxide, could help to trigger a runaway greenhouse effect, warming the planet and potentially melting the polar ice caps. Raising the Martian temperature is a daunting challenge, but it is essential for creating a more temperate and hospitable environment for humans. Mars' thin atmosphere offers little protection from harmful solar and cosmic radiation. To safeguard future Martian colonists, we would need to develop innovative shielding technologies. One approach involves incorporating radiation-resistant materials into the construction of habitats and structures. These materials would absorb or deflect incoming radiation, providing a safe haven for human inhabitants. Another intriguing possibility involves generating an artificial magnetic field around Mars. This protective field would deflect charged particles from the Sun, much like Earth's magnetic field protects us from harmful radiation. Protecting Martian colonists from radiation is a critical consideration for any long-term human presence on the planet. As we contemplate the possibility of terraforming Mars, we must also grapple with the ethical implications of such an endeavor. One pressing question is whether we have the right to alter another planet so dramatically, especially if there is even the slightest chance that life may exist on Mars, even in microbial form. Furthermore, who would have the authority to make decisions about how Mars is terraformed and who gets to live there? The potential for exploitation and inequality is a serious concern that must be addressed. The ethical challenges of terraforming Mars are complex and multifaceted, requiring careful consideration and open dialogue. Despite the challenges and ethical considerations, the prospect of terraforming Mars offers a tantalizing glimpse into a future where humanity becomes a multi-planetary species. Imagine a future where humans walk on Martian soil, breathing the air and drinking the water of a planet we transformed with our own hands. Such an achievement would represent a quantum leap in human ingenuity and determination. It would demonstrate our capacity to overcome seemingly insurmountable challenges and inspire generations to come. The journey to terraforming Mars would undoubtedly foster unprecedented collaboration and innovation, pushing the boundaries of science and technology and potentially unlocking solutions to some of Earth's most pressing problems. Terraforming Mars is a bold and ambitious vision, a testament to the boundless potential of the human spirit. While it remains a distant goal, the very act of contemplating such an endeavor expands our horizons and challenges us to imagine a future filled with possibilities. The journey to terraforming Mars will be fraught with challenges, both technical and ethical. Yet, the rewards of success are too great to ignore. By striving to make Mars a second home for humanity, we push the boundaries of our knowledge, ignite our collective imagination, and take a giant leap towards securing the future of our species among the stars. The red planet beckons, and the final frontier awaits.